Here is an overview of a sweep, a hyperparameter search that I ran for my deep drive project, which is applying semantic segmentation to driving scenes, identifying cars, humans, etc., for a total of 20 classes. And you can see that this sweep ran 201 different runs, and here's the improvement over time. Each of these dots corresponds to a combination of hyperparameters that was chosen, and you can see this line connecting the best ones. I set up my hyperparameter sweep to maximize intersection over union, and here in this parameter importance panel, we can see which hyperparameters were more important, and we model this with a random forest. You can see that learning rate was the highest, most important one, and it had a negative correlation, meaning that we should probably set a lower learning rate. Weight decay was the next one. It had much lower importance and a positive correlation, so we could increase that slightly. And you can scroll through the full list of hyperparameters here. You can also change the metric, what we're calculating parameter importance with respect to. And so you can see if I look at only a human intersection over union, then AlexNet, using AlexNet as an encoder, becomes the most important, and the correlation is very high. You can also see some examples here. Predictions across runs. You can see how it's doing and identifying cars. Here on the left we have the raw image, then the prediction and the ground truth. In this awesome figure, we can see how different hyperparameters relate to each other. So here you can see that the IOU, intersection over union, is the result metric that we care about. And some hyperparameters that are varying with respect to that are batch size, number of training stages, weight decay. And you can see that as I scroll through, you can see what the actual values for a given run are. For example, for Dauntless Sweep, and this is the learning rate. It's a very high learning rate and doesn't seem to do as well, batch size, etc. And I can actually click through to see all the details for this run. So here you see there's 3 encoder types. It's kind of a little bit hard to read. The yellow corresponds to better runs, so a higher intersection over union. So it looks like we pretty quickly found that this set does a lot better. So let's zoom into this region right here. It's a little large, but we'll figure it out. And here, okay. So you'll see that the bottom of our range went up by a lot, and you'll see that the lower learning rates here are generally positively correlated with higher IOU. You'll see that AlexNet here gets all of the purple runs, all of the ones that are slightly lower, whereas ResNet 34 gives us higher accuracy. And we can continue zooming in like this. Let's say just on this top set here. And now you'll see that AlexNet has even dropped off. None of the AlexNet runs performed well enough to be in this set. You can also move these around to get a better sense of the relationship between adjacent parameters. And those filters are applied here. You can always clear them again. They'll apply to all the charts in your workspace. You'll also see all the charts that you usually see, so validation loss, accuracy, and so forth. You can also see all of your system metrics, so GPU power usage. You can scroll through here. You'll get time spent accessing memory for each run in this sweep. Again, you can click through to all of those runs. So now, let's say we want to launch a sweep from some existing runs. So let's say we want to find some with the highest intersection over union for humans specifically, because those are the models we want to train. So we've sorted by that, and here are those best runs. So what we can do is select a few of these, let's say some of the best AlexNet ones, and let's just throw in some of the high-performing ResNet ones in there as well. So here I've selected 6 runs. Now I can go here and create a sweep, starting with those. And I'll get a YAML file that specifies my training program, method, what the metric is that I want to minimize or maximize. So let's say I'll actually change this to maximize validation accuracy. I can set a distribution. For my variables, let's say I want to keep some of these, and it'll do some of this for you. And you can definitely double check all of the values, but it has pretty good defaults. And once you're happy with this file, you can hit initialize sweep, and you'll get a command which you can then copy and then paste and run on any machine, whether that's your local computer or a cluster, etc. And then you'll get a dedicated page like the one I was just showing for your new sweep. And here are all the prior runs that I selected. And the command, which you can actually run on multiple machines, and the YAML file specifying the sweep. And then here you can manage your agent. I haven't launched any yet. And you can also always pause or stop your sweep from the UI, as well as see information about it.